Now we are going to take a look at the alternating series test. But before I do that, I wanted to go back and show you the general terms, the nth terms for your power series. So go ahead and pause and write these first three down. I have the other ones on other pages here. So make sure you have those and memorize those. These, like I said, well, you don't memorize these, you memorize the original ones, the four originals, and be able to plug them in or use substitution. And then for the fourth one, we did the derivative and then the integration. So I'll show you those here real quick too. So this one is, that was the integration. That was just the first couple terms there. The nth term, or the general term, is right here. So you're going to want to make sure you write that down. That was after, well, this is for the integration one, for the integral of ln x. So that's the last one. All right, so then we're looking at, for the derivative, let's see. So the power series for 1 over x, that would be this one. That was the first couple terms. And then the derivative of that would be right here. So make sure we write that down. Okay, so that's your rule. So like I said, you can take your rules from the originals and modify them based on the substitution or the derivative or the integral, or you can just look at the new pattern that you created and come up with the rule. So if you're really good writing the rules, then you should be fine. Some of us struggle with it, which is entirely fine. But the more you do them, the better you're going to get. All right, so let's take a look at an alternating series. So 3 of the 4 elementary series that we looked at, cosine, the sine, the ln x, and the e to the x. So 3 out of those 4 are alternating series. And what an alternating series means is that it is going between a positive value and then a negative value, and then back to positive and then negative. So it's just alternating between a positive and a negative term. So we have this thing called the alternating series test. So this is going to be our third test for convergence. So we have the nth term test, which we learned a couple weeks ago. We have the geometric series test, and now we're going to have the alternating series test. So we're going to have three tests for convergence here. We're going to learn a lot more as we move forward. But the alternating series test says in these cases, if you have an n as a power and n plus 1 as a power, 2 things must happen for it to converge. So n plus 1, and then it has to be less than or equal to a sub n. Okay, so what that means is the next term has to be smaller than the previous term at some point. So for all n's after a certain n, so just because it goes up for a little bit, as long as it comes back down and stays going down, we should be able to converge. Okay, so terms never increase in absolute value. So what we're thinking about is just the absolute value of these terms. Okay, it doesn't matter that they're negative or positive. The big one is then the limit of the a sub n. So just the part without the negative 1, we're going to take the limit of it as n approaches infinity. And it has to be 0 for us to be able to get value for convergence. So the first thing I want to look at is these 2 examples here. So now what we want to do is, real quick, we want to list out a couple terms. So if I plug in 1 for n, we end up with positive 1. If we plug in 2, we end up with a negative 1/2. And you can do these on your own if you want to pause them and make sure you get the same values that I'm getting. And then we get a positive 1/3, a negative 1/4. So just listing out the first 4 terms. we can continue on. But we see that we're getting smaller, okay? So we're getting smaller, each term is smaller than the previous one. So that meets the first condition. The second condition is that the limit approaches 0. Okay, so we have to double check that. So just because this is happening doesn't mean that it converges. So 1 over n. So limit as n approaches infinity for 1 over n. So if we plug in infinity, we get 1 over infinity, which we know equals 0. So this will converge due to the alternating series test. Okay, so converges. Second one, plug in some values. So if we plug in 1, we're going to get, let's see, we're going to get a positive value. Plug in 1, we get 2. If we plug in a 2, we're going to get a negative, so it's fluctuating between the negative and the positive. So plugging in 2, we get 3 over 2. We're going to get positive 4 over 3. And negative 5 over 4. Okay, so first couple terms laid out here. So we are getting smaller. So 3 halves is smaller than 2. 4/3 is smaller than 3 halves. 5/4 is smaller than 4/3. So we're looking at that and we're saying, yep, first condition met. But now we have to take the limit. So we're taking the limit as n approaches infinity of our a sub n. So just this n plus 1 over n part. So n plus 1 over n, and plugging in infinity, we get infinity over infinity. So we could run L'Hopital's rule, or we just know the shortcut. So we know this limit ends up being 1, which is not 0. Okay, so 1 does not equal 0. I'm just going to put that. So this diverges. Okay, so that's all we have to do with the alternating series test. Has to meet these two conditions for convergence. If it doesn't meet either one, it diverges. All right, so go ahead and try the homework. That you should be able to complete everything now. Like always, there are some tough problems on there, so please let me know if you have any questions.